Okay, so now we do questions, basically questions about electric field. Okay. So we go back to the paper and we try out the question. Hold on. Let me check first. Okay, good. So recording here. Okay. Question 17. Page 17. Sorry. Question 29. Yeah. Page 17, question 29. Can we answer? Okay, so what's answer? Yes, good. A. So horizontal motion will be constant speed. Vertical component will be acceleration upwards. Ay has a value. Ax is 0, so it's go constant speed. Okay, 29 should be A. Okay. Okay, this one. Page 20, question 27. What's the answer? Try to do as much as question possible. Okay, good. Good. So D. Yeah, good. Should be D, right? Okay, so one of you said, two of you said D. Okay, I'm happy. So few of you actively involved in answering. Keep it up. Yeah, should be D. So positive to negative. But when reach the negative plate and coming out from the positive plate, it have to be 90 degrees. So yes, please give importance to that. That's what they are checking. This should be 90 degrees. All should be 90 degrees. And reach the surface also should be 90 degrees. Okay,
But
good.
teacher,
Yeah.
Isn't the Earth positive also?
Yeah, the above positive here should be 90 degrees.
But when reaching the Earth, isn't it supposed to be like repel? Because Earth is positive.
Earth is you see, Earth take the opposite charge of the body always. Earth is actually neutral, but let's say a positive body is get closer, the Earth become like could be changed to like a negatively charged. Okay. So the field nothing to do with the field is for positive, just coming out from the body one. What's your question?
Oh, my question is, because Earth is usually positive, right? So isn't the positive and positive meet and then they repel each other?
Okay, so Earth not always positive. Earth is changing as what is the opponent charge is. When the cloud is negatively charged, get closer, the Earth surface tend to become positive. When you bring a positive charged body closer, the Earth will automatically change to negative. So the Earth can change the charge. Actually, you see, when you bring the negative body closer, the cloud get closer, the negative charges of the Earth, at the beginning, Earth is neutral, positive, negatives are mixed up. But when the cloud get closer, the negative charge of the Earth will go towards the center of the Earth, go away from the surface. So therefore, the surface tend to become positive. Okay. So when a positive charge you bring closer, positive can't travel. Positive cannot it's not mobile, right? Only negative is mobile. Why positive charge not mobile? Anyone? Why positive charge not mobile? Cannot move.
Because
Why?
it's in the nucleus.
Very good, very good. So it's inside the nucleus. A nucleus trap. As long as the mass does not displace, the positive cannot move. But electron can move. Electron go around. So when you bring a positive charge nearby, all the negative charges, especially the electron, will go away. No, not go away. All the negative charges from the center of the Earth will come to the surface. Come to the surface, become negative because they are attracted to positive charge. So Earth not always positive. It can change charge. Okay?
Okay.
Can,
Okay, thank you, teacher.
Okay, good. Okay, next question. After the question, yeah, this one. Yeah. Okay, page 21, question 16. What's the answer? What is the change in potential energy of the charge? Okay, what's up, me answer? The gain in potential energy or the gain in kinetic energy? It's all work done. Work done by the field. So when the charge moves from X to Y, how much is the work done? The gain in potential or the gain in kinetic? It's all work done. So what is work done by the field? The force. The force is F times which distance? Should be. So I'm receiving the answers. All are saying A. Okay, should be Fs. I think no doubt about that. So the work done should be cos F times S lah. Because F work is force times distance traveled to the direction of the force. Okay, good. But now check. Is it the potential energy rising or decreasing? How to know? What type of charge is this? X. X is what charge? Is it positive or negative? The charge is moving from point X. A positive charge. So X is a positive charge. It's a positive charge. And getting closer to the positive plate or negative plate. What plate is this? So this is the positive plate. This is the negative plate. So positive charge is getting closer to the negative plate. So when a positive charge gets negative plate, what happened to the potential energy? Decrease or increase? It will decrease. Potential energy will decrease. Kinetic energy will increase. Okay.
Positive.
So yeah. So if potential energy decreases means the answer should be, of course, it's A lah. A. The potential energy decreases by Fs. Okay. If the work done is 10 joule means the work done by the F is 10 joule means the potential energy decreased by 10 joule. The kinetic energy is increased by 10 joule. The charge getting faster when get closer to the negative plate. Okay, but magnitude wise work, potential, gain, kinetic energy, the magnitude wise all same. Okay, so if potential loss means kinetic will gain, but the magnitude is same as the work done. So good, all of you got A. A is the answer. Decrease. Why? How do you know it decreases? Because positive get closer to the negative plate. So unlike charges, so the kinetic energy has to become greater, attracted. Potential should drop. How much work done by the field? Any questions from here? Okay. You can. I go to the next one. Okay. Before I go to the next one, I have one question in my mind. Let me ask you this before we continue. This is a very important question came up in my mind. One of the past year again, they asked this. Okay, let me show you this. Okay, the question in my mind is this. They have a parallel plate as usual. Okay, have a parallel plate, positive here, negative here. Okay, two particle was launched into this parallel plate with the same velocity. Same velocity. The first particle is proton. The second particle is alpha particle, helium as usual, 4-2. Okay, so proton, alpha. Let me put the third one. 3 particles. Third one is same velocity, electron. Okay, electron. Okay, now the question is, out of proton, alpha, and electron, which deflect the most? Which deflect the most? Means which going to hit the plate earlier?
The electron.
Proton, alpha, electron, based on quantitative, based on calculation. Show me. 1 minute for you. You must have a reason. Okay, which is going to deflect the most? Who's going to be the number 1? Who's going to be the number 2? Who's going to be the number 3? I think better I put it all together. Okay. So, okay. So, one of you said is E, electron. Electron. So, okay, let's see. So, is it electron the most deflected? Okay, good. Another of you said all in order. You said the most deflected is electron, followed by proton and alpha. So the order, one of your friends said, is electron, proton, and alpha. The others? Okay, let me get more answers. Okay, electron, proton, alpha. Electron, proton, and alpha. Okay, everyone saying electron, proton, and alpha. I think all 3 answers I got, all of you saying this. Okay. So why electron? Okay, how to find the deflection? Which is going to make deflection more? The one has a greater force or the one has the greater vertical acceleration will deflect more? 1 or 2? Which deflect more, with a greater force or the greater vertical acceleration? Anyone? Which quantity greater means you're going to deflect more? Greater vertical acceleration or greater force? Anyone?
Vertical acceleration.
Yes, vertical acceleration. The one which has the greatest vertical acceleration will deflect more. Okay, so let's get a formula for vertical acceleration. So F equals to ma ay. So ay is F over m, but force is what? Is QE over m. QE over m. Oh yeah, correct. So QE over m. QE over m is your vertical acceleration. QE, yeah, correct. So vertical ay is depend to what factor? It depends to the magnetic field. It depends to the electric field, which for 3 of them is the same. And another one factor which determines the ay is the ratio of charge to the mass of that particle. This is the point I literally want to highlight here. The purpose I'm asking this question is about this factor. Charge per unit mass determines the deflection. So which has the greatest charge per unit mass? Okay, let's go for electron. Electron, what is the charge in unit mass? Charge of electron is what? 1e over the mass of electron is very little. Is 1 over 1830 times roughly mass of proton. Mass of proton. Okay, I put 1 over 1830 in terms of ratio of proton. Okay. So for case of proton, the charge is 1e. The mass is 1 unit. This mass I put 1 unit. For alpha, the charge is 2e because the The alpha is 4,2, is a 4,2 helium. The 2 is the charge, 2e. Over the mass is 4. The mass is 4. Okay. So which has the greatest ratio? I think the electron is 1830. The reading. A proton is like 1 E. These all are E. This E, this 1 E, and this ratio is half E. Yes. So of course the electron gives the greatest ratio of charge, so it should be number 1, and proton should be the second, which is 1e, and of course alpha is the lowest, half e. Okay, so electron, proton, alpha, this how this arrangement is correct. But I don't know many of you, do you realize this is the way of what you call getting concluded? You must put in your mind that deflection is more dependent to AY. AY, get the AY formula, force over mass, QE over M. The ratio of charge per unit mass determines the deflection. Because in the coming exam, they might not use proton, alpha, or helium. There is one year they asked like this. They put all the nucleuses are accelerated. The first nucleus is hydrogen, okay, 1,1. The second nucleus is helium, 4,2. Okay, which one deflect the most? Helium or hydrogen will deflect the most. This is 4,2, 4,2. So how do you calculate? Check the ratio of charge per unit mass for these two bodies. Hydrogen will get 1:1, but helium will get the charge per unit mass will be what? 2/4. Okay, so hydrogen will take the greatest deflection. It can deflect a lot. Then helium will deflect a lot. If it's a negatively charged. Okay, good. So that's the point I like to highlight here. Deflection. Any questions from here? Okay, so we go back to the past here. Okay, more questions? Okay, this question. This is a very good one. Page 21 again. Question 30. Reglas, give a try again. Question 30. Give me the answer. Send me your answer. What's up, your answer? What is the relation between V and U? So you have to recall back your projectile knowledge. What is the relation between V and U? V is the final velocity when it come out from the parallel plate. Use the initial velocity. Yeah, use the initial velocity. Okay, I receive answer. One of you said A. So let me wait for the others. So one of you said A. Is it A? Okay, I'm getting more A answers. So all of you got A. Yeah, few of you said A. So very consistent, good. Okay, let me say, is it A? So what is the electric field direction changes theta if it emerges from the B? How the relation V and U? Oh, this is the triangle. This is V. We can draw the triangle here itself. This V. This should be your U. Your UX is U. UX. This is your UX actually. U is UX. UX. The UI we don't know lah. UI we don't know. We have to calculate, but don't bother. This is your U. This is your V. Okay, so it's a triangle. Like the hypotenuse is V. Your horizontal length is U, is theta. So trigonometry. How V and U related? It's cos, right? Yeah, good. Cos theta. Cos theta is U over V. Yes. So V will be U cos theta. Good. The answer should be A. A. Those who understand the Vx, Vx, Vy makes the V. If you know this diagram, you can get the answer. The Vx is actually same as U, the initial velocity, what? Horizontal velocity. So you get this answer. Good. Any questions? Yeah, 30. So answer is A. Okay. Okay, class. I just one question in my mind. Okay. When this U get into this electric field, it move up with V. The deflection is theta. Okay. Tell me, what happened to this theta value? What will happen to this theta value when the charge particle go into this parallel plate, and at the same time the plate separation was reduced without changing the voltage? What will happen to the theta, the angle of deflection, if when it enters the parallel plate, the plate separation was reduced without changing the voltage? The theta will increase or decrease? Anyone? Increase or decrease? Can answer? So the plate separation decrease immediately. So E equals to V over D. The D suddenly decreased. When the D decreases, the electric field strength going to become stronger.
Yeah.
When the electric field gets stronger, what happened to the force become QE? The force get stronger. The vertical force gets stronger. Therefore, F equals to MA. The vertical acceleration going to be greater. When vertical acceleration get greater, which component get greater than supposed to be? The UI. The UI going to be longer than supposed to be when it crosses the plate. So the angle going to be, conclusion is, when AY increases, UI increases. When UI increases, the theta become greater. More deflection. When the plate is reduced, this is the flow. The E gets stronger, the force gets stronger, AY gets stronger, therefore UI increases, so deflection get more. Okay, some questions. Okay, good. More questions? Okay, this one I do. Okay, this one. Question 22. Give me the answer. Uh, 29, sorry, 29. Page 22. Which row describes the forces acting on X and Y? So, direction of force, radially, X and Y electrons. So, electron X, the force is radially inward or outward? So, what type of charge possessed by this body? Because of field going out, so it should be positively charged. Okay, so it's an electron, so the force must be going radially inward, right? So it should be radially inward. And yes, good answer is all B. Radially inward, also giving B. And greater than force on Y. Yes, force X is greater than force on Y because the field get weaker. So good. The answer is B. Okay, good. Okay, class. This one. 23, question 30. Give me the answer. Okay, this is a stationary experiment. The weight is not neglected. The weight is not neglected. The weight balanced by the force due to electric field. So it's like a parallel plate. Yeah. So it was stationary. So definitely the weight is mg balanced by the electrical force. Okay, so what is the weight of the particle? So of course, the weight of the particle should be same as the electrical force, force due to electric. So what is the force due to electric? So force due to electric, what formula? QE, right? Charge times the electric field strength, or Q times with what? VOD. VOD, yes, good, correct. VOD. The charge of the particle times the potential difference across the plate divided by the plate separation will give you the electric force, which is same as the weight. So what's the answer? So Q is Q of what? Oh, Q got it there. 4.8 times 10 power of negative 19. V is what? V is volt potential difference, 660. And the D is what? D is the plate separation law, 15 mm change to meter. Okay, so 0.015. So you'll get the answer. So anyone wants the answer? Yep. Anyone got answer? So
A, right?
A. What do you got?
A.
A is it? A, huh? How did you got A?
Because W
Yeah.
equals to QV and then W equals to FD. So I put F equals to W F equals to QV over D.
Hold on. F equals to QV over D, is it? Yeah.
Yes.
F equals to QV over D. Yeah, correct. Okay. QE over D. F from F equals to QE. QE. Yeah, correct. So what's the answer you got? A, is it? A.
Yeah.
A. Okay, good. So should be A. Okay, so this the calculation should end up giving the answer. So balancing weight must be equal to the electric force. Okay. Yeah, this question. Page, what page is this? Page 25. 209, paper 1. Question 27. This is, I think this is not that challenging. Yeah, both should be negative, right? Both should be negative because upper plate is positive. Upper plate is positive because they say the field line directed from Q to P. Q to P. So upper plate should be, sorry. The field line is, the plate are charged electric field Q to P. So down is positive. Q to P. Up is negative. So this charge is directing attracted to positive. So the both charge must be negatively charged. Good, the answer should be A. Okay. Okay, this one. Okay, good. Question, page 26, question 29. Give me the answer for this. Which expression gives the distance x through which the electron travels before it stops momentarily? Of course, the electron should slow down, right? The electron definitely slows down because electron moving towards negative plate, so it should slow down. This is your negative plate one. This is your negative plate. This is negative plate. This is your positive plate one. Positive plate. So electron going towards negative plate, it should slow down. That means what equals to what? The lost in kinetic energy is equals to the work done by the field. Okay, the work done by the field is equals to lost in kinetic energy. The field does work to slow down the electron. Okay, in this case, the field does work to slow down the electron. So yeah, so based on this, you have to calculate your what? Your distance. So anyone got the answer? The loss in kinetic energy. Loss in kinetic energy. What is the loss in kinetic energy? What is the kinetic energy they possess at the beginning? Half mv squared. Finally become stop. So the lost in kinetic energy is how much? Half mv squared. He lost kinetic energy of half mv squared. What is work done by the field? F times x. The force exerted by the field to oppose the electron, slowing the electron. Of course, when the electron moving to the right, the field going to apply a force to the left one, right? The force going to be to the left. You're going to slow down the electron. Yeah. So from here, work out the answer. The F you need to be replaced lah. Okay, I receive answer as D. So is it all of you got D? Is it D? You have to replace the force. So the others got D. So half mv squared. I'm getting more answer D. F is what? F is QE, right? F is QE. Q times E x. Yeah, you got the answer already. So x is what? X is mv squared over 2QE. But of course mv squared. Sometimes the charge they write elementary charge symbol E. Small e is the elementary charge symbol, charge possessed by one electron. Small a is equals to 1.6 times 10 power of negative 19 coulomb. Charge possessed by electron and proton. So they put E sometimes. The Q replaces with E. Okay, good. The answer should be D. So all of you got D. So here's the working should be. Okay, any question? Okay, so here the loss in kinetic energy is work done by the field. The field tried to stop the electron from moving forward. So the work done by the field is equal to loss in kinetic energy. Okay, or can say gain in potential also. If the question asks what is the gain in potential energy, the gain in potential also going to be the same amount as work done by the field, Fx. Okay. Okay, so more questions? Okay, this is a very good question. What page is this? This is page 28, question 27. Okay, 1 minute for you. Read it carefully. Give me that. Those who really understand the definition, I think you can get the answer for this. Okay, text me answer. So you can get the answer. Recall back definition of electric field strength. Then you can find the answer. Okay, I'm getting D as the answer. No doubt, the answer either B or D. It cannot be A or C. It's force per unit positive charge, right? That's the definition of electric field strength. But the positive charge is which charge? The charge possessed by the body which emitting the field, or the charge possessed by the test charge who experienced the force. That's matter. So you see here, small charge Q. I'm getting more answer. All of you say D. Man, still getting D. You see the small Q and the capital Q. Both of them have force each other. Of course, it's attractive. It's an action-reaction pair. So, what is the electric field strength of the charge Q? They're asking what is the field produced by the Q. What is the field produced by the Q? The capital Q. At the position of small q here. Okay. So who's the test charge here? The capital Q or small q? The test charge is the small q. The small q experienced force due to the field of capital Q. So the question asking for what is the electric field strength of the capital Q? So it's same as force per unit positive test charge. It should be a test charge. Who experienced the force caused by the capital Q? Is the small q. Correct. The answer is D. Okay, what is the answer going to be? If they ask what is the electric field strength of the charge of small q at the position of capital Q? What is the field produced by the small q? Field by the small q at the capital Q. So it's force per unit. Who's the test charge now? The capital Q is the test charge. This is electric field strength of the small q. Force experienced by per unit positive test charge. The charge at the bottom, remember, must be the test charge. It's the test charge. The question is the other way around. What is the electric field strength of small q at the capital Q? The answer should be F capital Q. The question asking for capital Q and small q, so the answer should be D. Okay, any problem? Can you understand?
Sure.
Yeah.
What's the difference between test charge and positive charge particle?
Okay, the definition for electric field strength is, let's say you have electric field here. You have electric field here. Okay, the electric field strength at this point is the force experienced by per unit positive test charge. So let's say here you have a test charge of positive 2 coulomb, and this positive 2 coulomb experiences a force of 10 Newton. So the field strength here is said to be 10 Newton divided by positive 2. So 5 Newton per coulomb line. But this field is caused by who? Caused by another charge is somewhere here. There is another charge somewhere here. Okay, maybe I put a capital Q. The field produced by the capital Q. Okay, so but in the formula, the field produced by the capital Q equals to force experienced by the test charge, the small q. Only the small q can tell the strength of the capital Q. Okay, like you see Earth has its own mass. You are standing on the surface of the Earth. Your weight is 80 kilogram. Okay, you experience weight of 800 Newton. You experience 800 Newton, let's say. What is the field strength? Field strength of the Earth. Field strength of the Earth is same as force per unit. Which mass? Test mass or mass of the Earth? Test mass or mass of the Earth? It should be the test mass. The mass which experiences the force. In this case, you are the test mass. So the field strength of the Earth is the force experienced by you, which is your weight, 800, divided by your mass, you are the test mass for the Earth. So divided by 80. So 10 is the field strength of the Earth. It's 10. So you want to find field strength of a charged particle, let's say capital Q. You want at one particular point. The force you must use is the force experienced by a test charge. And test charge is the one will tell the strength of the other body. Okay, so it should be F over small q will decide the electric field strength of the other body, Q, capital Q. Because you see, capital Q, is it affected by its own field? Is it capital Q experienced by its own field? Is it affected by its own field? To Earth affected by its own field? Is it Earth experience force due to its own gravitational field? Yes or no? Is it Earth affected by its own gravitational field?
No.
No, right? Who affected by its gravitational field? Another body, right? Another body, right? Same thing for electric field. You want to know the electric field strength of the capital Q means it should be force divided by charge of the test charge. Only the test charge can tell the strength of the capital Q, the other body. Okay. So what's your question? Do you understand?
Yes, I understand.
Good. Okay. Okay, let's move on. More questions. Okay, this question. Page 29, question 28. Yeah, try, everyone. Okay, so I receive answer D. So is it D? So charge per unit mass. So you're getting D. Oh, one of you saying B. B or D? So I got a different answer now. One saying B, another one saying D. B or D. So how to know? Okay. Oh, many saying B. Boy. Two of you saying boy, one saying D. Okay, how to find this? The acceleration of G and electric field strength, they are asking for the ratio. Of course, as usual, the mg should be equal to the electric force, which is QE. So of course, mg must be same as QE. So the ratio of charge over mass is charge over mass must be what? Should be G over E. G over E, right? From this formula. Okay. The weight, the force due to gravity must be equals to force due to electric. So yes, the G over E, the answer is B. G over E, or can be A also G over E. But check, the charge must have what type of polarity? It should be negative. How to know? Because the electric force must be upwards. For the electric force to be upwards, the charge of the particle must be opposite to the charge of the upper plane. Right. Upper plane is positive. The charge of the particle must be negative. Then only the electric force will be upwards. So it should be negative. So answer is B. Good. Answer is B. Okay. Next question, June 10, paper 11, question 29, page 29, question 27. Come on, give a try. 1 minute for you. This is a very good question. I want this answer. Please WhatsApp me, as you see who can get the concept. Okay. One of you saying is C. Is it C? I need answers from the others. Think carefully. Okay, one of you said C, another one said A. Two of you said A. Or three of you said A. Many said A. Yes, good. The answer should be A. It's A. The work done is 0. Why the work done is 0? Because the particle move in an equipotential line. Or in other words, because the center is positive, the circle radius positive point charge at the center of the circle creates electric field magnetic field, which expression gives the work done on a unit positive charge P to Q. Oh, there is another unit positive charge from P to Q. What is work done? Work done. So the force will be downwards, but the displacement is 90 degrees. Okay, the force, so the work done, force times distance traveled to the direction of force is 0. Because of what? The reason is force is perpendicular to the displacement. So work done must be 0. No work has been done. This is the same case for the satellite. The satellite, I told you the same story. The gravity also works the same way. The force downwards, but it displays sideways, perpendicular, when you go around. So work done is 0. So satellite not required any fuel because no work has been done on the satellite. Okay, so the answer should be 0. Reason is the force and distance travel is perpendicular at any moment. Okay, any question? Can understand? Good. Okay, next. Hey, last another one question come to my mind. Let me ask you this if I forget. Okay, this is also a tricky one. Okay, parallel plate. Okay, positive, negative. Electron was a proton is placed here. A proton moving to the negative, of course. This is the distance travel. Okay, d. Okay, so tell me, the proton was start from rest. It accelerates. Tell me how the graph looks like if you plot a graph V versus D. D is the distance from the positive plate. Okay, D. When the proton is moving from positive plate for a distance of D, how the velocity change? How the graph looks like? Definitely you're going to start from 0. Is it going to be a straight line? Of course, the velocity when reached here is going to be higher, but there are 3 options. It could be like this, or it could be like this. 1, 2, 3. Which one is correct? When the proton move to the right, V versus D graph. How the graph will look like? Definitely start from rest, reaching a maximum speed when reach the negative. But is it going to change in a curve with the decreasing gradient, or curve with the increasing gradient, or linear straight line? With your reason. I want a reason. Give me your reason. You can WhatsApp me answers again. 1, 2, or 3. You must have a reason behind why you say that. Okay, definitely proton is start from 0 meter per second here. When it reach here, the speed is going to be very high, maximum. Yeah, so it must start from 0 to V max. It should be V max. But is it going to increase with the curve with a decreasing gradient, or with the increasing gradient, or linear? Please send me answer. Okay, I got answer. Answer your friend, one of your friends saying that what? It's 2. So one of you said it's 2 because you said constant acceleration Okay, yeah, it's a constant acceleration. Therefore, it should be a straight line. Yeah, constant acceleration will yield a straight line if you plot v versus t time. This is v versus displacement. V versus time, yes, is going to be a constant straight line. Okay, so I receive answer. One of you said 3, another one said 1. Okay, 3 or 1. 3 or 1. Oh, good. 3, yeah. Okay, so many saying 3. One of you saying 1. Only one saying 1. Two of you saying 3. Okay, first, my clue is get a formula relating V and D. Can you find one formula relating V and D? One kinematic formula relating V and D. Then you can get the shape ready. What one kinematic formula can relate V and D? D is actually like displacement law. V and S. What formula relate V and S? Kinematic formula. V squared equals to U squared plus 2AS. Yes, this is the formula relating the V and S. D is S law, right? Yes, this is the formula must come to your mind. You want to know the shape of the graph, you must know the relation mathematically. So we know U is 0 because it starts from S. So V squared equals to 2AS. So this is the relation. Maybe let me put more mathematical. V I put it as Y squared because you are maths, you are more prone to Y. So V squared I change to Y squared. And 2A is constant because it's moving with a constant acceleration. 2 is constant. So constant, I put a number, fixed number. Maybe I put 10, just to visualize the shape. S, maths, you'd like to put X. So how this graph looks like? Y squared goes to 10X. How the graph looks like if you plot Y versus X? How Y squared equals to 10X graph looks like? Y equals to 10x squared, the graph looks like what? Quadratic lah, going up like quadratic. If y squared equals 10x, if y is squared, how the graph looks like? Like this, right? Like this, right? Y squared equals to 10x. So answer should be what? Answer should be 1. So 1 is the answer. So 1 is the correct answer. So V versus D for the particle should move like this, 0 to V, with a curving with a decreasing gradient. Based on what formula? Based on this kinematic formula reveals their relationship. V squared equals to 2S. V squared S, like V is like the Y squared. The curve should be this way. If your maths is quite strong, you can imagine the curve should be this way. So the answer is 1. Okay, should be 1. If Y equals to 10x squared, then it can go for 3. But not x is squared. The y is squared here. The v is like y. V squared. So it should be curved down. Should be 1. Any questions? Okay. Okay. Good discussion today. Many of you involved. Okay. I want more of you like participate. Okay. Good to participating. Whether it's wrong or right is fine. You just give a try. Okay. Give a try. Participate. It's good for you. Okay. Learning process. So any question from here? Do you agree it's 1? So you want to find the shape of the graph, you must get a formula linking the y and the x axis first. Most probably going to link to kinematic. Kinematic. Okay. Yes. So the answer should be a 1. Okay. So if you don't have question, so then we can stop here. Tomorrow, you go through the electric field first. Tomorrow, maybe the first 15 minutes, we try out. If you have any questions, you can ask me. If you don't have, what I want you to do is, I want you to try with sets. Okay, go back to your, sorry. Okay, go back to your times. Douglas, sorry, I was disconnected. It's okay. I stop here. So tomorrow, please do the papers, do the semester papers. Then I see you tomorrow. Any questions? No questions, Okay, thanks.